All right, we're going to watch this video for your notes today. You have to excuse my voice. I don't have much of one right now. We're going to be doing 3-1 proportional relationships. It says here that a proportional relationship is a relationship between two quantities where the ratio of one to the other is constant. So it's the same each time. So if I look at this table, I have 1 over 3, or 1, 3, 2 something, 6 something, x 36, 20,000 something. Now, what we have to realize about uh, this table is it does have a x and a y. Our x is the top, and the y is our bottom. And then it says the way we write the ratio is in the form y over x. So this first ratio we're going to make is 3 over 1. Okay, and then the next one is 2 over, excuse me, something over 2. We need to figure out what something is, or what this is, what this x is. This is what y is. Y over x is y over 2. So we need to figure out what y is. With this being consecutive, this is 1, 2. So how do we need to see what, since it's the next step, we just see what we multiplied here on the bottom to get the next step. So to get from 1 to 2, we had to multiply times 2. So we can multiply that times 2. And 3 times 2 is 6. And if we were to reduce that, it would equal 3 over 1. 2 goes into itself once, and 2 goes into 6 3 times. Now the next one, it skips a little bit to 6. So that is y over 6. So what we need to figure out, this needs to be equal to 3 over 1. So what do we have to multiply here to get from 1 to 6? Well, 1 times 6 is 6. And we need to multiply the top times 6. So 3 times 6 is 18. All right, and then the next one, we don't know what the x is. We don't know if it skipped in here or not, but it has to equal 1/3 still. So, and this is going to be 36 over x, so 36 is on top this time, and we need to find the x. Excuse me, I wrote this backwards. This is 3 over 1. So I need to figure out what did I multiply times 3 to get to 36. So 36 by 3, and you get 12. So 3 times 12 is 36. So I'm going to multiply the bottom by 12. And 1 times 12 is 12. If you were to reduce that, 12 goes into 12 one time, 12 goes into 36 3 times. It gives you the same 3 over 1 ratio. And then this last one, we have 20,000 for x, and we don't know what our y is. So we need it to equal 1/3, or not 1/3, 3 over 1. It needs to equal y over 20,000. So what did you have to multiply times 1 to get 20,000? Well, 20,000. So we're going to multiply top and bottom by 20,000. So 3 times 20,000 is 60,000. And now we have what goes in each one of these. So for 2, we got 6. For the 6, we got 18. For the 36, we got 12. And for 20,000, we got 60,000. Okay, and this is a proportional relationship, or the table is a proportional relationship, because each one of these, when you do y over x, reduces to 3 over 1. It has the same ratio. Let's go to the next slide, next page of your notes. All right, this is an example. This example is proportional because the ratio of miles to leagues is the same each time. Actually, I think this is the same page. It says a proportional relationship can be described with the equation y equals kx, or k equals y over x. That's supposed to be a line there. All right, k is called the constant of proportionality. This is the number you get when you find the ratio. In our example, k is. So what do we find that k is? Well, you go back to this, we do K equals Y over X, we found that is 3 over 1, which equals 3. So K is 3. So K is 3. So the equation for our example is Y equals 3 for the K, because K is 3, X. So that would be the equation for that table. Okay. When a graph is proportional, so that's how a table is proportional. Now we're going to look at graphs. A graph is proportional when it starts at 0, 0 and is in a straight line. So when we look at a graph, we go, did this line start at 0, 0? 0, 0 being right here, did it start? No. So it is not proportional. Okay. And the next one, we look at this line, did it start at 0, 0? Yes. Now we must answer the question, is it a straight line? Yes. So this one would be yes. That's the next one. Does it start at 0, 0? Yes. Is it a straight line? No. So this would be no, or not proportional. The next one, does it start at 0, 0? Yes. Is it a straight line? Yes. So this one would be yes. So to be able to tell if a graph is proportional or not is much easier than a table. You just have to know where it starts at 0, 0 and must go in a straight line, just like these two right here. All right, moving on. My notes got cut off a little bit. When a relationship is proportional, it is said to have direct variation. Okay, so proportional, direct variation, these are all the same thing. They mean the same thing. If you're given a table, a graph, or a word problem to see if it is proportional or to see if it has direct variation, we're going to find K using K equals Y over X. If K is the same for each ratio, then yes, it's proportional, and yes, it has direct variation. So this K equals Y over X is going to be very important when we're dealing with a word problem or a table, not so much a graph, because we can use is it straight and does it start at 0, 0. So let's read this example. Megan earns $12 an hour at her part-time job. So this is dollars per hour. Dollars per hour. All right. Show that relationship between the amount she earned and the number of hours she worked. Is what's going on here? This is part of my notes. Let's go forward. It is a proportion. So what we would do here is we would just set up a table. Megan earns $12 an hour at her part-time job. All right, so I'll read the rest of the problem. So, show the relationship between the amount that she earned and the number of hours she worked is proportional relationship. Then write an equation for the relationship. So, if you go work a job, you're going to know how much you get paid per hour. So, but you got to also know how many hours you work. So on top, we're going to have our hours. Time is going to be always going to be on top. If you make a table, time is always on top. So hours and the amount earned. Okay, you need to make sure you're making this table with me. So I'll try to draw as straight as possible. It's going to be really crooked. All right, so this is our X on top. X is always on top. Y is always on bottom. Okay, so how many hours could we work? We could work 1 hour and get paid $12. What if we work 2 hours or 4 hours or maybe 8 hours? Okay, that's for like a day. And then we could even do, what if we work 40 hours for the week? Okay, so what is our constant proportionality here? Well, our constant proportionality for this is going to be y over x. K equals y over x. So in this first one, our y is 12. Let me get that a little bit. Let's put it in here. So K equals y over x. So for the first hour, that is 12 over 1, which equals 12. For the second hour, we need it to equal 12. For fourth hour, equal 12. For the eighth hour, 12. And if we wanted to go ahead and do 40 hours, it needs to equal 12. So all we're going to do is see how many times is the bottom number going to here. I'm sorry. What can we divide by 2 to equal 12? So basically, we're just going to multiply these two numbers. So if we go back to the front page of our notes, I'm sorry, there we go. We can get our y by doing k times x. We essentially have our k. Okay, we have our k, which is 12. Have our x. 2 times 12 is 24. The same thing. 4 times 12 is 48. 8 times 12 is 96. If we wanted to do for 40 hours, we do 40 times 12. And we get 480. So now we can plug in these numbers into our table. 24, 48, 36, 480. Okay. All right, so then write the equation for the relationship. All right, so let's move on to down here. So find k for each ratio. So we did. Find k, we got 12. Is k the same for each time? Yes, it is. All right. You got double sign. So 5k for each ratio. We found that k equals 12. It is the same each time. Is it proportional? Yes, it is proportional and has rate variation. The equation for this is y equals 12x. That would be our equation for that table. All right. Next page. Sorry that my notes are cut off on the smartboard. Yours are not. It says 15 bicycles are produced each hour at the Speedy Bike Works. Show that the relationship between the number of bikes produced and the number of hours is a proportional relationship. Then write an equation for the relationship. So we're just going to build another table. Okay. Now we have hours because it's produced each. We have 15 bicycles produced each hour. So we have time. Time is always on top. So hour. And number of bicycles. Spell this right. Okay. So this is our y. This is our x. So it said in 1 hour we can do 15 bikes. So we need, let's just do say 5. Random number, we'll just go by 5. 5, 10, and 15. So our k equals y over x. So we'll do this first one. So that's 15 over 1 equals 15. Then we're going to do the next one. 5 for our x. This has to equal 15, so we're just going to do 5 times 15 is 75. And then we need to make sure that does equal 15. 75 divided by 5 is 15. And then our next one is 10 equals 15. So 10 times 150 is 15 is 150. And then our third one, um, something over 15 equals 15. So 15 times 15 is 225. And they all equal 15. And that is what makes this table proportional. So we're just going to write 75, 150, 225. So up here, it says, so he wants to show the relationship between the number of bytes produced and the number of hours is a proportional relationship. We did that right here. Then write the equation. So y equals k, our k equals what? 15, and then x. This is just the form y equals kx. That is the equation form that we're using right now. All right. Next table. The table shows the relationship between temperatures measured on the Celsius and Fahrenheit scales. Is the relationship between the temperature scale proportional? Why or why not? So now it's given us all the numbers and it wants us to prove if it's proportional or not, or to see if it's proportional or not. So here's our what? Excuse me. Our x, there's our y. Put that back with all ago. Sorry if I confused you there. That's why 15 was on top. Apologize for that. All right, so what we're going to do is we're just going to do y over x for each one of these numbers. Okay, I'm not going to sit here and do each proportion. We can use our calculator. For the first one, 32 over 0, we can't do. So we're going to go to the next one. We're going to do 50 over 10. So k equals y over x. If we do 50 over 10, you get 5. If you do the next one, 68 over 20, in the calculator, 68 divided by 20 is 3.4. So I don't have to go any further. Excuse me. I'll write down the pen here. 3.4. So these are not the same. So this is, no, it is not proportional. Why or why not? Because ratios are not the same. Are not the same or are not the same. Or constant. It's the same thing. Constant and the same are the same thing. On a graph, points are plotted and labeled using x, y. X is the horizontal axis. Horizontal is going this way, and y is the vertical. Vertical is up and down. All right, we can use points on the graph to find k using k equals y over x. If k is the same for each point, the relationship is proportional and has rate variation. So let's flip over to this page and look at this example. All right, the graph shows the relationship between the weight of an object on the moon and its weight on Earth. Write an equation for the relationship. So it has points here. 1, 2, 3, 4 points. We have this point. We always run and then jump to get our points. So if I run here, I'm going to get 6. That's 1. So 6, 1. I run here, I go 12, 2. So it's 12, 2. Next one is 18, 3. And the last one is 35. So 35. All right, so now we have x and a y. These are, that is x, and that is y. It's the same for each one of these points. All right, so we label the coordinates for each point. Now it says find k for each point using k over yx. So for this first point, 6 over 1, or 6, 1. X is 6, y is 1. So y over x would be 1 over 6, which equals 1 over 6. You can even do it as a decimal and get the same decimal. The next point is 12, 2, so that would be 2 over 12, which equals 1, 6. The next one is 18, 3, which is 3 over 18, which equals 1, 6, because 3 goes in 3 one time, 3 goes in 18 6 times. And the last one is 5, 30. 5 goes into 5 one time, 5 goes into 30 6 times. So all of these are constant, the same. This says, is k the same each time? Yes. Write the equation using k equals yx. So that should be actually y equals kx. It's a typo. So it is y equals 1, 6, x. That is our equation. All right, moving on. One more. The graph shows the relationship between the amount of time that a backpacker hikes and the distance traveled. What does the point 5, 6 represent? So what does this point represent? So let's look at our first thing we're going to do is we're going to look at the labels of the x and y axis. All right, go ahead and label my point. So it's 10, 12. And what was that? 15, 18. Okay. There's my x, there's my y, there's my x, there's my y, x, and y. All right, so what does this represent? The x says time, and this says distance. So what does the 0.56 represent? Well, this is time in hours. So at 5, that's 5 hours. And this is 6, that's 6 miles. So I mean 6 miles hiked in 5 hours. Okay. What is the equation for this relationship? First, we need to find k, and just make sure it is proportional. So we know that k equals y over x. So the first one is 6 over 5. The next one is 12 over 10. And the last one is 18 over 15. So we want to see what they all reduce down to. 6 over 5 is reduced as far as it can go. What goes into 12 and 2? Or 10? 2 does. 2 goes into 12 6 times. 2 goes into 10 5 times. 1 goes into 18 and 15. 3. 3 goes into 18 6 times. And 3 goes into 15 5 times. So all of these are the same. So k equals 6 over 5. So our equation would be y equals 6 over 5 x. All right, so that's our notes. If you take a look at your homework for tonight, you have some problems with graphs. You got 1, 2, 2 tables there. Just doing y over x, find the k, answer each question. And then you got a couple more graphs, a couple more tables. It's 9 problems. Make it, if you have a graph, make a table. For instance, on number 6, Number 7 already has a table there drawn up for you that you can use. You're going to need to draw a table for number 8. Number 9 already has a table and a graph, so you just have to answer those questions. And then on the front, 1, 2, and 3, use are they proportional or not? Zeros, does it start at 0, 0? It is in a straight line. Number 4 and 5, you just have to complete the table. All right, I'll be back tomorrow. Come with questions. Have a good day.